Hi everybody and welcome. Today we're going to be talking about solving equations. So your goal after watching this video will be able to solve two-step equations, and also your goal will be able to understand the concept of equality and the balance of equations. So starting us off today, the example that I think of when balancing equations is basically always, if anyone's a fan of The Office, I think it's at Dwight's farm, the Connecticut Casual Picnic episode where Kevin and Ryan are on the seesaw. Now, I didn't want to put a picture of that in case anybody didn't get the reference, but kind of the idea is that Kevin wants to play on the seesaw. He's a little bit bigger than Ryan, so when they try to play on the seesaw, it ends up that Kevin is just kind of on the bottom of the seesaw and doesn't move, and there's nothing that Ryan can do because he needs a little bit more weight. So the idea for the picture today is that there's something wrong with this picture. And the idea behind this, and this is to make you think, is what is wrong with this? So we expect the seesaw to have more weight on the side that is down. So we would expect, because on the left with that mouse, we would think that the mouse would be the one that's up in the air. And the idea is that, again, weight brings you down. Now, a balanced seesaw would have equal weight on both sides, and if we had that balance there, what we would see, again, would be kind of like a level. We would see it would go straight across. But in order for the mouse to actually weigh down this side, we would need it to weigh more than the elephant weighs. So we would probably need a few more mice all throughout here, maybe like hundreds of mice to weigh this side down. But the idea of the seesaw is also the same as the idea of balance, in that more weight means you're heavier, less weight means you're less heavy, but on the whole, in order for our seesaw to go across like this, we would need equal weight on both sides. So balance is the key for today. And our big picture is, how do we get balance on this seesaw? So we have a lot of weight here, and we have a little weight here. So to get to the idea of balance is we would probably take some of the weight from here and bring it over to that side until we had, let's say, 100 pounds on both sides. And that is truly when we are equal and when we are balanced. That's why the equal sign goes kind of like straight across, right? It's like a balance. But this one here, little weight and lots of weight, not balanced. That won't work for us. So when you think about equations today, think about Kevin and Ryan, and think about how maybe Ryan would need Kelly to go on the side with him. So he would need someone else to jump on that side of the seesaw in order to balance Kevin. Otherwise, he's never going to move. They're never going to see balance, and the seesaw won't work. All right, so a couple definitions for today. And we are going to start off with, let's see, make sure I'm on the right one here. We're going to start off with coefficient as our first word. Sorry about that delay. So with coefficient, this is going to be the number or quantity we multiply our variable by. So for example, if we had like 2x plus 7, right here the 2 is our coefficient. You've probably heard me refer to this before quite a few times, our constant. That is just a number with no variable. So when we're going through to solve an equation, we got to get the variable by itself, which means we want a coefficient of 1. So our first job is to eliminate the constant, so get it away from the variable. And then second, we are going to isolate the variable using the inverse operation on the constant. So an inverse operation just means opposite operation. So if we had addition, that would be subtraction. Subtraction would be addition. Multiplication, the opposite is division. The opposite of division is multiplication. So basically, you're just doing the opposite to create balance. So the idea is that, if you're multiplying by 4 on one side, you have to multiply by 4 on the other side. If you're going to, take 10 pounds away from one side of the seesaw, you have to take 10 pounds away from the other side of the seesaw. Otherwise, you won't have a working seesaw. You won't have balance. So let's do one of these equations together, and I'll leave you the other one to solve. I always draw an algebra line down. That's how I make sure that I always have balance, and I'll show you how. If we subtract 12 on the left, we need to have a mirror step on the right. So it needs to look exactly the same on the right side. So we're just left with here x on the left and 14 on the right. I know that it's balanced because every step of the way, I have done the same thing to both sides. So I took 12 pounds away on the left, took 12 pounds away on the right, and my seesaw still works. If I want to check this, if I plug 14 back in for x, and I add 12 to it, what I'll see is that 14 plus 12 does equal 26. So if I had Ryan and Kelly, they will equal the weight of Kevin, and this will be a balanced seesaw. So that's kind of the concrete example of why solving equations like that works. All right, so one final step that we're going to do today that directly relates to this, and we actually just did an example of it. We're going to be looking at equality, and mathematical equality to be more specific. So this is when two quantities have the same value. So the idea, again, if we're on our seesaw, if we have 26 pounds here and 26 pounds here, that's an example of equality. A non-example of equality is we have Kevin here and Ryan weighs less than him. This is not equality. So we're checking basically to see if we have balanced seesaws when we check for equality. So first we replace our variable with the constant term that we're given. And then second, we evaluate the equation and follow PEMDAS to see if it's balanced. So still using the order of operations here, still an important step for us. So let's go through and try a few examples of these before we go on. So 6 examples, these are a little bit quicker to do. So we're just going to do the first one, and I'll give you the remaining ones to continue. So it's asking us here, x equals 7, is that a solution? So rewrite everything. The only difference that I would like to see is that instead of the x, we're going to use parentheses. So we're going to plug in 7 for x, and then now we can go through, follow PEMDAS, and evaluate. So 7 times 5 is 35. We add 12 to it, and we're checking to see, does that equal 37? Well, 35 and 12 give us 47. That does not equal 37. So here's an example of just Kevin and Ryan. This is an unbalanced seesaw. So is it a solution? It is not a solution. Go through the rest of these, and again, we're looking for balance. So if the left equals the right, we have balance, we're happy. If it doesn't, then it's not a solution, it does not work. So we're checking to see, is it a solution or is it not a solution? All right, as always, any questions, feel free to reach out here to answer them. I appreciate everybody watching the video, and I will see you in class.